artificial insemination, and why would a livestock producer want to AI his breeding stock? Artificial insemination is the process of collecting sperm cells from a male animal and manually depositing them into the reproductive tract of a female. Artificial insemination is commonly used instead of natural mating in many species of animals because of the many benefits it can have. These benefits include increased safety of the animals and producers, increased production efficiency, and better genetics.
Artificial insemination was the first great biotechnology applied to improve reproduction and genetics of farm animals. It has had an enormous impact worldwide in many species, particularly in dairy cattle. The acceptance of AI technology worldwide provided the incentive for developing other technologies such as sexing of sperm, estrus cycle regulation, and embryo harvesting, freezing, culture, and transfer, and cloning. New highly effective methods of sire evaluation were developed. The history of development of AI is reviewed particularly in dairy cattle, in which the impact in genetic improvement and control of venereal diseases have been greatest.
Other species briefly included are swine, horse, sheep, goats, dogs, rabbits, poultry, and endangered species. Major landmarks in AI development are cited, along with the people most closely associated with these developments. Many of these pioneers helped to develop a new generation of reproductive technologists and biotech.
Beef cattle greatly outnumber dairy cattle in the United States. The technology of semen handling and insemination of beef cows is similar to that used for dairy cows, but beef cows are not managed as conveniently for AI. Many cows are on extensive ranges where detection of estrus and rounding up animals in estrus for insemination is not cost effective. AI has the advantage because semen can inexpensively replace maintaining bulls of separate breeds.
Research on AI on horses started in Russia in 1899. Although methods have been devised to freeze stallion sperm, most equine AI is done with cooled, extended semen used with 48 hours of collection during the spring breeding season. The breeding season may be advanced by fall lightning.
The earlier development of AI in sheep on a major scale began in Russia also. Both rams and bucks can be trained to serve as artificial vaginas. However, for obtaining semen from a large number of rams in the field, electrocution is a useful procedure. Because of the difficulty in insemination, general management, and low value per animal, AI, particularly of sheep, is not widespread.
The AI of swine was initiated in Russia in the early 1900s. Pregnancy rates and litter sizes are reduced with cryopreservation boar sperm, so frozen semen is limited to use in special breeding programs. Fresh or extended liquid semen is used for about 99% of AI in swine. Rapid transport of extended semen makes it feasible for swine farmers to take advantage of commercially produced boar semen. Large corporations increase the service possible for their own boars by using AI. Insemination is done by the swine farm personnel. Techniques for evaluating quality of boar sperm are similar to those used of bull sperm. Sexing boar sperm is possible, but is too slow to produce sexed sperm for commercial use. Detection of estrus is facilitated in sows because most come into estrus within a week after weaning their litters.
Artificial insemination has been widely applied to poultry. With the ease of collecting poultry semen and proximity of hens on large breeding farms, AI is used extensively with freshly collected semen. It is used 100% for turkey breeding because mating is difficult. Freshly collected chicken semen was among the first type of semen to be frozen. However, cryopreserved poultry sperm are less fertile, and freezing poultry sperm still is experimental.
Although the dog was the first animal in which AI was documented, AI has only been used in special cases, such as for breeding guide dogs or for overcoming special problems. Many breed organizations do not register puppies produced by AI. Rabbits have been extensively used as a model for large animals and humans. All the reproductive technologies developed with farm animals can be performed with the low-cost rabbit model, and certain placemental characteristics make them especially recommendable for studies of human teratology.
The most widely used test of sperm quality for the initial stages of the AI development until the present time has been the assessment of the proportional of normal, progressively moving sperm. With frozen semen, evaluation of post-thaw survival has become important. With the AI expanding rapidly, demands for semen from popular bulls increased. The simplest way to meet this demand was to stretch each ejaculate further by using fewer sperm per insemination, providing that this could be accomplished without sacrificing fertility.
While the geneticists were making breakthroughs on sire selection, an astounding achievement was reported from England in 1949, the successful freezing of chicken sperm by including glycerol. Glycerol soon was found to be useful for bull sperm. This soon became the most commonly used medium worldwide for cryopreservation of bull sperm and sperm from several other species. Fertility is still lower in many cases, but cows can be inseminated at a fixed time without detection of estrus.
One of the most dramatic technology advances in recent years is the sexing of sperm by DNA qualifications using flow symmetry instruments developed at the Livermore laboratories. The time currently required to sort the billions of sperms per ejaculate limits